In this example, we are asked to determine an equation for a function, and we're just given the graph of the function to work with. So if we're going to find the equation, we need to find the values for these parameters a, b, c, and d, and then put them into our equation. A, of course, is the amplitude. We can get our amplitude by finding our maximum and our minimum values here. So we've got a maximum value up at 2, a minimum value at 1. So our amplitude is going to be that maximum value plus that minimum value, minus that minimum value divided by 2. So 2 minus 1 divided by 2 is going to be 1/2. So we got an amplitude or an A value of 1/2. B is our vertical translation here. We can get that by averaging our maximum and our minimum value. So we can do 2 plus 1 divided by 2. That is going to be 3/2 or 1.5. And these both make sense here. If I sort of put in that little dotted line here at 3/2, we can see that our amplitude here is 1/2, and that line, that midline there has been shifted up by 3/2. C is related to our period. It's 2 pi divided by the period. So we need to determine the period of this thing here. So we're shown one complete cycle from here over to here. So we've got to figure out what that's going to be here. If we sort of extend our labeling here, this is -3 pi over 2, so this would be -2 pi, and over here this would be +2 pi. So it looks like our period is 4 pi. So 2 pi divided by 4 pi is going to give us 1/2 for our C value here. D is our phase shift. And to determine our phase shift, we have to decide, are we working with a sine function or are we working with a cosine function? A sine function, we expect it to start right on this mean line that I've drawn dotted in red at x equals 0. Now what we see starting from this point on the mean line is that it goes down. Now with a sine function, we would expect it to go up. If it's going down, we can interpret that as a reflection in what would have been the x-axis, but in this case it's reflected in that midline. So if we choose a sine function, we can have no phase shift. Let's say d equals 0. So if we're modeling this with the sine function, we would just have y equals our a value here, which is 1/2 sine our c value, which is 1/2, then x, d value is 0, plus 3/2. Now if we really needed to model this as a cosine function, what we could see is that for a cosine function, we expect it to start at its maximum here. So where's this maximum point? It is right here. So the maximum has been shifted from the 0 point this way by how much? Well, by pi. So a shift of pi to the left would suggest that our phase shift is -pi. So if we use a cosine function, our d value is -pi because it's been shifted to the left. So our equation would be 1/2 cos 1/2 x. If our phase shift is -pi, we're going to see a positive in there, plus 3/2. So whether you choose a sine function or a cosine function, those are both equivalent, and that is the equation of our transform function.